आपका वॉल्यूम थोड़ा कम रखना पड़ता। शुरू हो गई मेरी क्लास शुरू हो गई। Okay, good morning students. Let us begin our class. 1 minute. Okay, students, Jagdish and who is there? Bhavna and Jagdish, have you gone through the material?
No, ma'am.
Yeah, ma'am.
No.
Yeah, ma'am.
Jagdish, you went through?
Yesterday, me, Nandini, and Srinivas went through the topics you said in the yesterday's class, ma'am.
Okay, very good. Did you understand?
Yeah, ma'am. We understood yesterday's. From last 2 days, me and Srinivas were understanding. Before classes, we need to revise once again, ma'am. Means we will once go through the material, ma'am.
When will you go through? I said tomorrow is our doubt clarification class. Then
Today
when do you
we will
want?
go
Today will you go through
50 unit, ma'am.
chapter 5?
Yeah, ma'am.
Today you go through. Tomorrow anyway there is a test also. And that is only 10 marks test. Bits. Fill in the blanks. Or short, very short answers. One word answer. So that you can complete in 10-15 minutes. And rest of the time we will address your doubts.
Okay, ma'am.
Okay. So yesterday everything is clear. So I can go ahead.
Yeah, ma'am.
It is good, Jagdish, that you form a group and then you study, because what happens is studying in a group will give you more insights about the subject. So, did you write? Are you able to convert the binary program into symbolic microprogram?
Ma'am, again, is the time, ma'am.
Srinivas?
Yeah, ma'am. Good morning.
Morning. Did you try to convert the program from binary to symbolic or symbolic to binary?
I try to converting, ma'am, but again confusing is appearing at second address, second binary address.
What is confusing? Which page number?
Same one
This
here in that second line.
second line. So what is this address you're telling? Or this last address, all zeros you're talking about, or second line?
Second line, ma'am. Here first line F1 110 mean PC to AR and
Hmm.
F no,
Hmm.
F3 no. CD
Hmm.
is always one
Hmm.
unconditional thing.
Hmm.
బ్రాంచింగ్ లో జంప్ అవుతుంది కదా మేడం, జంప్
Hmm.
అయినప్పుడు అడ్రస్ అనేది
Hmm.
ఇంక్రిమెంట్.
Address here. What jumping means, it can jump to next line, it can jump to any other place. Jumping, unconditional jump means it can go anywhere, even to next line also.
How can we write address, ma'am, here?
Here address part AD contains the address part, no?
Yeah, ma'am. Yeah, address 1000001. How it is?
Okay, that is there is no, that is something hypothetical. There is no logic behind that. You can take any address. It's
In my
like they.
point. I am thinking that here F1, F2, F3, CD, B are based on these five field. The address will be changed, and I thinking that.
No, 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 no. It is
I also
not
thought the
based on.
same, ma'am.
No, no, no. It is
In the
not
second
based on
one,
that. It is the address of the instruction. This AD part is nothing but the address of the instruction. Micro instruction. This is the address of the micro instruction.
But it should be
This
compulsory 8-bit, no, ma'am?
it should be compulsory 7-bit because our address, our control
Yeah, ma'am. 0
memory,
to 7.
our
it-
current.
okay, ma'am. But it converting automatically, ma'am.
What it is converting?
Here binary address 1 0 0 0 0 ma'am.
Hmm.
Address is the address of the next one. No, that's why it is coming for next one also.
Here this it is like this. I will tell you, wait. This is 1, this is 2, this is 3, or I can start from 6, I can start from 7. Means I can start from 6, 7, 8, or I can also start from 100. First address of micro instruction can be, first micro instruction can be anything. That is not fixed. That is depends. It depends on the availability of the memory. So if you look at these three addresses, um, what is happening here? Here, uh, 1 2 3. This can be 1 2 3. This can
Okay,
be
ma'am.
6 7 8. This can be 6 7 8. This can be 100 101 102. So
Mm.
what will be here? Here, because it is 1, here it is like 2. This is like 2. Hmm? This is like 2. I will get back.
Morning, Jagdish.
గుడ్ మార్నింగ్ రా. ఇవాళ ఒకటే కదా, ఇది ఒకటే కదా.
ఎందుకు మేడం ఆ మేడం కూడా చెప్తారంట కదా 12కి.
అరే స్టాట్స్ సమ్ములు చూసి కూడా అర్థమైపోతాయి రా.
మేడం అయితే మేడం అయితే
డేటా అయిపోతుందిరా నాది.
అయ్యో.
రేపు ఎట్లయినా కంపల్సరీ జావా ఉంటుంది, ఇది ఉంటుంది. రేపు ఎట్లయినా 2 అటెండ్ కావాలా.
ఉమ్?
రేపు ఎట్లయినా 2 కంపల్సరీ అటెండ్ కావాలి కదా.
ఆ,
రేపు అయితే
శ్రీనివాస్ ఈరోజు ఏమేమి క్లాసెస్ ఉన్నాయి?
స్టాట్స్
హలో
ఉంది, సిఓ ఉంది.
ఓకే.
ఆ,
రేపు 3 క్లాసులు జావా కూడా రేపు.
జావా
రేపు
ఇంకా
జావా, సిఓ, స్టాట్స్.
Okay, students, I'm back. So here what I meant to tell you is these addresses are not at all related to this part. This part is different. This part is like these addresses. This is 1, this is 2, this is 3. So what happens? Here it will be 2. Here it will be 3. Here it will be nothing. Means 0 means no, it is ending, like going nowhere. No need to go also anywhere, like that. Now you tell me what is your doubt. Did you understand this point?
ఎస్
Srinivas,
మ్యామ్.
Jagdish, did you understand this point?
ఎస్ మ్యామ్.
And
ఎస్ మ్యామ్.
0 మ్యామ్.
This zero means okay, because we are starting at 0, it will go to 0th address, means the first address.
Okay, ma'am. Yesterday you gave some homework to us, ma'am. In that, you told me binary address is whatever we can take, that is binary address, and address is automatically it will change, anarga, ma'am.
Address will
Here,
automatically change.
add, branch, over, store, ఇవి వీటికి ఎట్లా తీసుకోవాలి మేడం? యాడ్ అంటే బ్రాంచింగ్ అన్న వీటిని ఇనిషియల్ బైనరీ అడ్రస్ ఎట్లా తీసుకుంటారు మేడం వాటికి?
That is, here it is given, org.
CDBR is change, ma'am.
org org
Wow.
means initial address. whatever is the value of org, that is the initial address. So initial address, it can be chosen depending on the availability of addresses, or depending on the size of memory, or depending on the size of program. This org will specify the starting address.
Okay, madam.
Here it is 0. Tell me, any other
Add
one?
labels, here labels a add, branch over, and address part lo indirect to next fetch అని some words are there, ma'am. వీటిని బైనరీ ఫామ్ లో కన్వర్ట్ చేయడము.
Okay, I'll tell you. So what happens?
ఆపరేషన్స్ కంటిన్యూస్ బ్రాంచింగ్ చేంజ్ చేసాం మేడం. ఓన్లీ లేబుల్స్, అడ్రస్ పార్ట్, అక్కడ ఉన్న టర్మ్స్ ని బైనరీ అడ్రస్ కి చేంజ్ చేయడం ఎట్లనో అర్థం కాలేదు మేడం.
This is which chapter? 8th chapter. Now we will try to understand. Oh my god.
ఫస్ట్ ఫేజ్.
Yeah, look at this. With great difficulty I went there. It has gone to again first page. Okay. So here look at this program. So what is happening is, these are decimal addresses. Okay, these are their binary equivalents, means address in binary form. Now these are our micro operations. Okay, and this entire thing is our micro instruction. From here this point to this point is our micro instruction. So the first address is 0 here. Then this is 1 4 zeros and double 1. 1 4 zeros and double 1. Where is the address?
None of them, ma'am.
None of them. Why they have given like that? Okay, because it is a partial, maybe. Okay, we'll look at this one. That is partial, so maybe they have not given. So okay, I will tell you this one. So this is address number 0, because we are starting at address 0. So this is address 0, and the label of this address 0 is add. So NOP means no micro operations. I means what? CD I means what? What do you mean by I?
0 1.
0 1. What does it means?
Indirect address bit, ma'am.
Indirect address. Indirect address means what?
Direct address is 0. Indirect address is mean 1.
It's indirect address bit when DR is 15 means it is having 1 at the 15th location.
Yeah, ma'am.
So what is this BR?
Call 0 1. Address goes to control address register.
Address goes to control address register.
Or subroutine branch routine అనేది ఇంక్రిమెంట్ అవుతుంది.
Call is subroutine, branch and return.
Written incremented to control address register 1.
Call means what are you doing? Whatever is there in AD, you are putting in CAR and you are incrementing CR and storing in SBR if condition is 1. So
1.
we are giving condition 1.
Yeah,
CD is 1. So
Mm.
this will happen. Now let us see what is happening. What is happening here? Here, what is the next address? If you consider this to be 0, this is 1 and this is 2 and this is this here origin is 4. So here we are starting at 4, 5, 6, 7 and here origin is 8. So you are starting with 8, 9, 10. Here origin is 12. So 12, 13, 14, 15. So this is 64 means 64, 65, 66, 67, 68. So 67, address number 67 has a label indirect INDRCT. So you are now address part contains this address indirect, maybe 67. In binary it is 67. 60. This is 64. This is 64. This is 65. This is 66, 67. So this address 67 has got a label. What is the label? Indirect. So what you are doing here, after this statement, you are moving the control to this indirect here. Okay, you are coming here. What are you
Okay.
doing in this? In this you are reading. Reading means what? How will you translate this into micro operation binary codes?
100 ma'am. Memory of address register goes to data register. అప్పుడు రీడ్ అవుతుంది.
F1 is, what is the
F1
code?
F2
F1 is
F
no.
no ma'am. F2 in F2 read is there ma'am. 100.
Okay, very good. So those nine binary bits for F1, F2, F3 will be 000. And what is the code for read?
Read per code 100 ma'am.
Okay, so 100 and 000. In order to translate this in binary, this will be 000 total, because you have to write F1, F2 and F3 all. So 3 zeros. And
F1 00, F2 100,
F100 and F3 will be
F000.
all 3 zeros. Okay.
Okay.
So
And
this is our binary code for 9 bits, first 9 bits in the micro instruction, that is read. U means
U means always 1. అంటే
always
CD
one. Always one. JMP means
సేమ్
what,
00 అడ్రస్ అనేది కంట్రోల్ అడ్రస్ రిజిస్టర్ కి పోతుంది.
whatever is the address that you are jumping. So next means you are going to next address. Next means next address. What is the next address? 68.
68.
Next is 68, no? Because
Yeah.
we have started with 64. So this was 64, 65, 66, 67, 68. So in this place, next you will get 68. So you are jumping to address number 68 here. So what is the code for this? DR to AR. You are copying, you are
One,
transferring the contents of DR into AR.
101
101
000
000 000. So for F1 it is 101, F2 it is 000, F3 it is 000. So you get 9 bits code for 3 fields, that micro operation fields, as 101 000 that is here, this part. Then U means always it is true.
Same.
RET means what? Now tell me, what do you mean by RET?
Subroutine return call goes to control address register.
From where we came here?
First indirect.
Here. From this address we went to that subroutine. These are like subroutines.
Okay, ma'am.
Okay. From here we have jumped there. From here we have jumped there means what we should do in return? In return should come to location number 1, no?
Yeah, ma'am.
Return should come to location number 1 because when we were in location number 0, we jumped to there using indirect address.
Okay.
So now after we come back to this, what are you doing in this? You are reading. And U means 1, JMP means it is jumping. Jumping can be jumping, whatever is the address given here, it has to jump there. What address is given here? Next. So what is next? Next is address number 2, means add. So you are reading. What did you do in this? In indirect subroutine, you have read the DR contents. You have transferred DR contents into AR in indirect routine. Now what are you doing? You are reading and you are performing the add operation. Add, again what are you doing to do add? U means 1, JMP means you have to jump. Where you have to jump now? What is the address given here? The address given here is fetch. What is fetch? Fetch address is 64. The address of fetch is 64. So you are coming from here to here. Okay, fetch. What are you doing in fetch? PC to AR, transferring the contents of PC into AR. And then this is again unconditional, and then jump next. Next means what is the address? 65. What are you doing here? You are reading the contents and you are incrementing the PC. Look, Srinivas and Jagdish and all the students, here this program is for this control unit. Try to understand that program was for this control, for this implementation of control unit. Look at here, what does this do? This is the control unit part. What is happening in control unit? You are having F1, F2 micro operation bits, F3 micro operation bits. All the three are having three, their size is 3. So when you use a decoder, you decode 3 bits into 8, one of the 8 bits, 0 to 7. So if you look at here, these are going as timing signals. Look at here, F1 add means this add, what does it add? It is like a timing signal to perform add operation in the ALU. ALU will perform add operation. ALU will perform AND operation. ALU will perform this DR to AC operation. But what these three are doing? These three are giving the signals when this ALU should perform these operations. When this ALU should perform the operations, as well as it is giving the signals to this multiplexer and to AR. See, when you are performing DR to AR, DR to AR means you have to give the signal to multiplexer and as well as to AR, because this multiplexer is getting, see, multiplexer is connected to this DR and multiplexer is connected to this PC also, and PC to AR to perform this operation also, it is connected to AR. Okay, it is connected to AR because you are performing operation on AR. So what is this all about? This whatever we are studying, that program, it will not actually perform the real operations. It will instruct the ALU part and other units in the processor to carry out that particular operation at that time. That is all about that. And see, if you consider this, this is nothing but the implementation of that microprogrammed control unit by using separate entities. But here, did you get this idea? What we are doing here? Okay, let us come back to this program again. So in this program, the whole idea of this is, it should give the the signals, means it should enable the ALU to perform add operation, to perform read operation. So whenever it performs this operation, a signal will be generated, and this signal will be given to ALU. Then ALU will perform. So where we are at fetch. What are we doing in fetch? In fetch, we are copying PC to AR. Fetch, if you remember fetch, at time T naught, what are you doing? You are copying AR is equal to PC. And then what are you saying? You are saying IR is equals to M of AR, comma, PC equal to PC plus 1. Fetch instruction, if you remember from chapter 5. In fetch instruction, we are doing this. At time T naught, we are doing this operation. AR equal to PC. At time T1, you are reading the contents of memory into this IR. Yes, tell me.
Memory of address register goes to data register and PC goes to PC plus 1
Hmm.
for at the time T2.
Yes, so at time T2, PC equal to PC plus 1, which is like
Yeah,
increment PC. It is like increment PC, no?
yeah, ma'am.
And what do you mean by read? Go to that micro operation and check what do you mean by read.
Memory of address register goes to data.
You are getting the contents from memory and storing in some register. It is IR or DR, depending
DDR.
on the implementation. Depend here it is DR. In chapter 5, if you look at, it was IR. So
Okay.
depending on the implementation, read means you are taking the memory contents and transferring it into some register, IR or DR.
Okay.
So that is this is T1. What is happening in T2? In T2, you perform decoding and reading
T
of the mode bit, and also you are AR is equals, if you remember from chapter 5, at T2 AR is equals to AR is equal to M of um, z, 0 comma 11, not IR. AR is equals to AR is equal to IR of 0 comma 11. Do you remember this? In memory reference instruction, the first 12 bits are addressed from 0 to 11. So what are you doing? That again you are copying into AR register. Hmm? Srinivas,
Yeah, ma'am.
are you getting? So what are you doing at time T3? At time T3, again you are getting the address part of instruction into AR. So that you are doing at time T3 here. Means here instead of IR you are using DR.
Okay, ma'am.
It all depends on implementation. This is all examples. These are not specific to any computer. You are taking some examples and then you are trying to understand the conceptual ideas about a uh, construction of a computer system
Oh,
components. So here it is time T3. So fetch instruction implementation is this. Okay.
okay.
Next, what
Mm,
happens? What is map now? Tell me what is map. What is map? Can you just go back see and tell me?
Map is a one part of data link layer. And it is address.
What is address? Mapping means whatever is there in the whatever is there in the instruction, some part of it will be taken as the bits for address, and then you add some more bits to it and make it 7 bits address. If you go back, if I flip back the pages to this map, in map what happens, look at here, dr of 11 to 14, 11 to 14 bits of dr you copy in car, means control address register, in the position 2 to 5, and then control address register 016, you are initializing to 0. This is mapping. um, we had mapping earlier also.
Yeah, ma'am. 4-bit to 7-bit address changing, ma'am.
Yes, see, look
Mapping.
at here. Look at here. This is 4-bit from computer instruction.
Can add a 0 on left side and right side, so you can change.
Giving append and suffix.
Yes, suffixes 2 bits and prefix 1 bit, then it will become a 7-bit address. Then it, and this process is known as map. So why are you doing map? You are doing map because here you have to get the dr part 11 to 14. Dr is in here, in this context it is data register, which just now into which we have copied the instruction. Okay, in that program sequence, if you remember, we copied the instruction from memory into dr. So this 11 to 14 bits contain the address part, and this you have to store now that part into car, but the size of car is 7 bits. So 2 to 5 you will get from dr, and 016 you are putting 0 in that place. This one, did you understand? Dr to ar means, dr to ar means what? You are copying the contents of dr into ar by using the map method. What is the map method? car of 0 to 5 is equal to dr of 11 to 15, and car of 016 is equal to 0. Did you understand? Yes, students.
Ma'am, here at the first stage origin 0. No, here address part is indirect address, yeah, ma'am. Indirect address mean whenever it came, it goes to the last. I mean 67th bit. It goes to 67th bit, yeah, ma'am. Here is indirect first.
Hmm. Hmm.
In
Hmm.
that address, we can go through the last one, indirect read and TR to AR operations.
Hmm.
Here address is 000. We can do, ma'am, F1, F2, F3. These address store at the first place, ma'am.
60. This 67 will be stored at 67 will be stored here, because you are jumping to 67 location, no?
Okay,
This
ma'am.
this indirect is the label. This is the label to the address 67. The address is 67, but the label is indirect, INDRCT.
Okay.
Hmm?
These address goes to at this place.
Yes, 67 will go to this
Yeah.
place. And what will go to this place? 2.
Next,
2.
sec,
Here in place of next, here the address value will be 2. What will go in the place of this fetch?
It's here. It is
64.
64. 64 at PC to AR.
Here you will get a 64. When you are translating the program, the symbolic microprogram into binary program, then these these numbers will be helpful to you. You have to convert these numbers into binary form, and then you can convert this program into binary program. Yes, students, I know it is a bit complicated. I totally understand, but you try to understand and relate the things, then you will also get it. Okay, so now branch. What is this branch? Branch, this is a label. Label means what? Okay, what is a variable? Tell me. If I say int a, what is a?
A is
A,
a very stores
huh,
a value.
variable. What is a variable? What do you mean by variable?
Location.
Variable means
Variable is
it
stores a
Memory
uh,
location.
it is variable is the name given to variable is the name given to the memory location. Hmm? Variable is the name given to memory location. Here also we have memory locations, and we are giving some names which are called as labels to memory locations. Understand? Yes, Srinivas?
okay, ma'am.
Okay.
Some little bit is understand, ma'am. I will try to understand again after this class.
Very good. So label is nothing but the name given to a memory location. Label is like a variable. Variable is also a name given to a memory location. In RAM, you have memory addresses. In RAM, you have memory addresses, and these memory addresses will have these memory location will have memory addresses. This address is very difficult to remember because it is in numeric form. So instead of remembering the address, you can assign a variable name like A. This is an address in numeric form. So here also these are addresses. If we say origin 0, so it will be the next address will be 0, 1, 2, and this is the label, means the name given to the memory address 0. Okay, so next what happens is branch. What are you doing in this branch? Branch is also a label, uh, and what is the address of it? 4, because
Or
the origin of it is 4. Nope means you don't have
F1,
any,
F3.
yes, any codes for F1, F2, F3. All are nope. And S is what? CD of S means? Here you are checking the sign bit.
AC of accumulate
Is S means sign bit?
of
So
AC.
yes, you are checking AC of 15th bit. Jump means if if sign bit is 1, you
One and
jump.
uh,
You jump. So suppose if the sign bit is 1, you jump. Where do you jump? You jump to over. What is over? Over is this, a label given to memory address 4, 5, 6, 6, memory address 6. Over is, so in this what happens when you, if you jump to over, you have nope and I um, call indirect.
address, indirect address.
Indirect address means again this part will be executed if you are coming to this. And if you are coming to this statement, means this micro instruction at address 5, then you are going to
Right.
fetch. Here actually this program is not complete, it is partial program. It is just showing how an add operation will be implemented, how a branch operation is implemented, and how a store operation. Do you remember store? What is the purpose of a store? Store means you are saving the contents from accumulator into memory, right? Store, sta is what? Store micro operation. So store, what does store micro operation do? In this store, uh, all micro operations F1, F2, F3, nope. Then this is I, and you are calling to indirect. What does indirect do? Indirect will execute all this PC to AR, read, increment PC. No, sorry. Indirect means it reads, and it perform read operation and copy of
DR.
DR to AR. And then what it does next? AC to DR. Uh, Look, students, try to understand any one functionality, and then rest of the functionalities you will understand. Okay, try to understand any one functionality. Add, we have studied just now, we have learned add, but I think it is not that clear. Let us look at store. In store, what does we do? Store means from accumulator you copy the contents into memory. How that is implemented? So to implement that, first you have to execute this operation. Read operation means first you are reading the instruction into uh, no, what is read means? Read means you are reading the memory contents, no? What does read means?
Memory of address register goes to data register.
You are reading the memory contents into DR. Read is reading the memory contents into DR. Okay. First you are doing read, and then you are doing uh, DR to AR. This is what DR to AR means. DR has some address that you are transferring to AR. After this, you are returning. Where are you returning? You are returning here. After returning, what are you doing here? AC to DR. You are copying the contents of AC to DR, and unconditional jump to next. Next means what? Next instruction is write. Now, what is write? Can anyone tell me what is write?
Write mean data register goes to memory of address register.
Yes, you are copying the contents of DR into M, memory, M. So, store means that only, no? Storing means storing the contents from register into memory. It can be any register. Try to understand these things are not particular and specific to any particular computer. These things are like we are taking different examples to understand different concepts. Here, store, the main purpose of store is to copy the contents of, to transfer the contents of register into memory. Are we achieving that through this subroutine or not? Are we achieving or not? We are achieving, no?
Yeah.
First we are reading, then we are doing some task here, and then we are writing back into memory. So store operation is fulfilled, no?
Okay.
Okay. Now what happens in exchange? Let us look at exchange. What happens in exchange? In exchange, uh, you are AC to DR and DR to AC you are doing. How are you doing? First you are going to indirect here. Why are you going first to indirect block subroutine? Can anyone tell me why are you going? Why these all subroutines or operation? These are actually micro operations which are implemented as subroutines. These are also implemented as subroutines. So why this every operation is going to this indirect? Can anyone tell me here? What are you doing in indirect? You are reading the contents of memory, no? To perform
Yeah.
any operation, you have to know the, so you should have some data, right? So from where you will get the data to perform an operation?
At indirect address only we can read the address register,
Yes, at indirect at indirect subroutine only you are reading
reading
the contents of memory into DR. Yes, no?
yeah.
So to perform exchange, to perform store, to perform add, to perform any operation, first you should have some data, right? So from where you will get the data or instruction? You will get the data or instruction from memory, no? That's why all these operations are calling indirect, because in indirect subroutine only you are reading the memory contents and then you are performing these operations. After you read the instruction into DR and you perform a read operation. You perform another, because you are exchanging, so you perform one more read operation, and then what are you doing? You are copying AC to DR and DR to AC, means it is exchange. You are putting the contents of AC into DR and DR into AC.
DR into AC to DR.
AC to DR, DR to AC. From where you got AC to DR and from where you got DR to AC?
AC to DR mean 101, ma'am, coding.
If it is F1 or F2?
0.
It is F1 or F2 or F3?
AC to DR, F2, DR to AC, F1.
F1.
Yesterday
So
we learned F1 and F2, two cases changes at the same time,
yes, it is.
automatically.
Yeah, it is possible, no? Yesterday we saw, no?
Yeah, ma'am.
So same thing you are doing here again. You are exchanging, means we are putting whatever is there in AC into DR and whatever is there into DR into AC, and then again next. Next means
Right,
what?
right.
You are performing write operation. Write, where are you writing? You are writing into memory. Write means write into memory, no?
Yeah, ma'am.
Again you are jumping to fetch. Why are you jumping again to fetch? Can anyone tell me why are you jumping here again to fetch? To start next instruction cycle.
Fetching.
Fetch is the first phase of instruction cycle, no?
Yeah.
Fetch, decode, read effective address and execute. After the execution of this exchange operation, you have to begin fetch again. Why you have to begin fetch again? Because you want to start another instruction, next instruction. Did you understand? After completion of exchange, suppose if you want to do store, or okay, in this manner we will go in this manner. After you execute store, again you are calling fetch. Why are you calling fetch again? To suppose the next operation is exchange. To perform exchange, again you have to do all this fetching of the, means reading the address and then reading the memory contents into DR and incrementing PC, and again getting the
So,
address, DR to AC, and again you will perform all this indirect. It is like fetch, indirect, and fetch indirect exchange, or fetch indirect store, or fetch indirect branch, or fetch indirect add. Are you able to understand? No? Okay, I will tell you with an example. After you read one, suppose you have a notebook. After you read the contents of first page, you will go to second page, you know.
yeah, ma'am.
So sometimes you go to second page, sometimes you will go to fifth page, sometimes you will go to 10th page. It is possible, no?
Yeah, ma'am.
So what is happening here? Here you are trying to execute a instruction, means program. You are trying to execute a program which comprises of instructions. So what happened? First instruct after reading first page is like executing first instruction. So after you execute first instruction, what do? You may go to next page, or you may go to fifth page, or you may go to 10th page. To do that, you may again start from index page. Suppose why you start from index page, maybe you are maintaining an index in the notebook and you note down all the topic names and page number. So after you read one particular topic, you don't want to go to the next topic, you want to go to some other topic in which you have doubts. So you have to go back to index page, get the page number, and you have to go to that page number and start reading that topic. Is this
Yeah,
point clear? So you have to first fetch. Fetching is like reading the index page. In
yeah.
the
We
in
want
the
the continue
yeah,
to go to the next page
yes,
and
yes. Suppose if it is your habit, after you read first page, you go again to index page and see what is there in the next page. Okay, so it's like reading one page, going to index, no trying to find what is there on which page, and again going to that page, reading, again going to index page, again getting the topic name and page number, again going to page and reading the matter. It is like that. This is like that. Fetch is
okay,
compulsory. Fetch is compulsory because unless and until you fetch an instruction, you cannot execute.
okay, ma'am. It's clear.
All of you. Hmm?
This
All
example
the
is
this example is clear. With this example, it's clear.
uh,
Okay,
Yes,
so
ma'am.
all the students, please try to convert this program into binary and try to understand. This is a partial program. You may not totally understand. Here, the gist of everything is that you should know. You should know fetch. You should know this reading
Indirect.
from memory, and
indirect.
then yes, that is indirect. And then you learn what is add, what is exchange, what is branch. This you please try to analyze today, and also try to uh, do this program also. I'll try to explain. I'll just go through why they have given some random addresses, and this figure also you try to go through, and also this figure also you try to go through. If you have any doubt, we will tomorrow we'll complete this chapter. So here if you look at, this is our control memory. In our control memory you have micro operations 9 bits, CD condition 2 bits, branch 2 bits, address 7 bits. And here you will get 2 bits of condition, 2 bits of branch, and this is address part. These are micro operations. And then here you will choose from condition, you have 1 I S Z. So one of them will be chosen based on the value. And what is this branch? Branch will take this condition bit, and it will decide whether it is external mapping, whether it is just next address. Okay, and CAR incrementer is just to increment the address when wherever you find next. It is like CAR increment, and this multiplexer will take all this and choose any one based on the micro instruction values. Okay, students, any other doubts? Any other, all the students. This is not for only one student. This is for everyone. Any doubts, Amarinder, Sri, Srinivas, Pavani, Jagadish, and who is this? Nandini. All of you, please go through the topics, and tomorrow you have exam at 11 o'clock. Now, it may be at 11 to, it will start at 11 o'clock and end with by 11:15, 11:20, like that we will end and we will continue. You all come to online and then take test. Okay?
Okay, ma'am.
Okay, then see you tomorrow. Bye bye.